Now we are going to start with another part of this reflection, like as we did the reflection for plane mirrors. Now we are going to start with the reflection by spherical mirrors. So the first thing is that what are spherical mirrors? What are spherical mirrors? See, spherical mirrors are those which have curved surface. The surface can be curved like this, and the surface can be curved like this. So we come across two spherical mirrors. This is called as concave. You can relate it with the upper side of the spoon. And this is called as convex. So concave is that in which the reflection occurs from the inner side, and this is a polished surface. Reflection occurs from this side. And here the reflection occurs from this side, and this is a polished surface. So this is the convex one. Now we are going to start with the basic terminology, that what are the terms which are involved in this. So the first thing is that, the first definition is that you should know that what is an aperture. What is an aperture? This is an aperture. Let's say A and A dash is an aperture. Similarly, we can say B and B dash is an aperture. So what is aperture? Aperture is a part of spherical mirror, because if you will draw it, it will become a sphere. But reflection at a time doesn't occur from whole sphere, it occurs from a specific part. That specific part is called as aperture. Part of spherical mirror from which reflection actually take place. So it is a part of spherical mirror from which reflection actually take place. That is called as aperture. So as I told you that if we will complete this, it will become a circle, it will become a sphere. The center of the sphere, is called as center of curvature. So what is, we have another term now. What's that? It is center of curvature. So what is center of curvature? It is center of spherical mirror. It is center of spherical mirror. Now the line passes straight through the C. This line, like if I draw a line passing straight through the C, this line is called as principal axis. This line is called as principal axis. So what's that? Principal axis is a line that passes straight through C. C is center of curvature. So the line that passes straight, this or this, is called as principal axis. Now the point where this line strikes the mirror, as you can see, this is the point where it is striking the mirror. This is called as pole. This is called as pole. So what is pole? Another term. Pole is a point on mirror where principal axis strikes the mirror. It is the point where principal axis strikes the mirror. As you can see that it is striking here, so it is a pole. It is striking here, this side, this is a pole. Now let us talk about the nature of the concave and convex mirror. So we see that if we talk about nature of concave mirror, it is said to be converging mirror. I will discuss with you that what does these terms actually mean. And convex mirror is diverging mirror. Now what do we mean by saying that? See, suppose these are the rays which are incident on concave mirror. It will get reflected like this. It will get reflected like this. So what we observe that like as many as means, suppose there are so many rays which are falling on the concave mirror. So whenever they will reflect back, they are going to meet at one point. They are going to meet at one point. So this kind of mirror which make all the reflected rays meet at a point is called as converging mirror. So that means if we talk about the nature, so our concave mirror is converging mirror. As I told you, what is converging mirror? Converging mirror is that which make all the reflected rays meet at one point. Which make all the reflected rays meet at one point. Which make, I'll write here, which make all reflected rays meet at one point. Suppose you need to draw a figure also. So just draw it this way. Let this be your concave mirror. This be your principal axis. This be your center of curvature. So make many reflected, many incident rays. Let's say this, like this. So they will be reflected like this. It will reflect like this. It will, and even this will reflect like this. This will reflect like this. This will also reflect. So it is going to make all the reflected rays meet at one point. So that is why we call it as converging mirror. And what about convex? Suppose these rays are striking it. Right. So they will also get reflect. So they will reflect here like this. You know that bouncing occur in the same direction. So what it is doing? Does it making all the reflected rays meet at certain point? No. It is just splitting the rays. It is just splitting the rays. So this kind of mirror is called as diverging. So wherever you are using convex mirror, you should know that it is a diverging mirror. Their nature remains same. It never changes. So diverging mirror is that which make all reflected rays, you need to mention that what rays? Reflected rays. Make all the reflected rays split in different direction. So that means if we talk about nature, so concave is converging and convex is diverging. I am just drawing a figure again. So let's say this is my convex mirror, principal axis, pole, center of curvature. This ray is falling, reflects back, ray reflects. So it is a splitting in different directions. So this is what we mean by saying diverging mirror. Now we have another term, focus. I'll write here. And we have another term, focus. Now what is focus? Focus is that point where the reflected rays are actually meeting or where they appear to meet. We see that, like if we talk about concave mirror, let's locate where the focus is. So focus is a point where all reflected rays meet. So this is that given point where all reflected rays are meeting. So this is called as focus. So focus is a point where all reflected rays meet. And as you can say, they are actually meeting. So that means concave mirror has real focus because it is actually meeting. But here if we talk about convex mirror, you can see that it is just splitting in different directions. So is it meeting? No. But if we take an hypothetical situation, or if we extend behind the mirror, suppose I extend this ray behind the mirror, I extend this also ray behind the mirror, so they are meeting at certain point. So that is again called focus. But because they are meeting imaginary, so we say that this focus is virtual focus. So I'll just complete the definition first. So it's a point where all reflected rays meet, or also a point where they appear to meet. Both are called as focus. So concave mirror has real focus because they are actually meeting, and the convex mirror has virtual focus because they just appear to meet. And one more thing, we'll be discussing that this distance and this distance is exactly half. So as I'm drawing with a rough hand, so don't get confused. This distance is always a half of this distance. So keep in mind whenever you're drawing, just make use of scales so that you should show clearly that this distance is what and this distance is what. Now another term, we have focal length. Focal length is distance between pole and focus. This is this distance. This is focal length. And even here also this is called as focal length. So what is focal length? It is distance between pole and focus. It is distance between pole and focus. And one more term we have, radius of curvature. It means radius of spherical mirror. So it is a distance, obviously the center point is this. So distance between C and P. It is distance between center of curvature and pole. So this complete is radius and this is focal length. And you know that there is a relation between focal length and radius of curvature. What's that? Focal length is always half of radius. Focal length is always half of radius. That means this is always half of this distance, and these distances are exactly same. So that means the complete radius is just half of focal length, right? And this is what is how we relate focal length is half of radius. So I think you got it. These are the certain definitions, the terminology which we are going to use in this chapter. I think you got it, that what is actually an aperture, what is center of curvature, this point, what is principal axis, the line coming straight, pole, point where it is striking, nature, concave is making all the rays meet at one point, it is just splitting, so it is converging and diverging, and focus, point where it actually meet or appear to meet the reflected rays. So real focus, virtual focus, focal length, distance between P and F, again P and F, radius of curvature, distance between P and C, again P and C, and relation between focal length and radius, it is all focal length is always half of radius. Now we will start with the rules, like what are the rules actually which we follow when we draw a ray diagram, and how we are going to draw a ray diagram for different situations. So just look at the board. So don't get confused, it is not a difficult one, right? Just do it in a happy mood and you will be just thorough with it.